bundles export the same version of a library, then the first one is chosen, the first one that shows up. If they export different versions of it, and that's actually something that's going to slip into the version 2.0, 3.0 I mean, they will actually have different, for the major versions of the software, they will have different packages. So you can export one that implements 2.1 and you can export one that implements 3.0, and then both of them get installed. But the tricky part with packages is that when a bundle exports a package, it states which version number it is right now. And the way the framework is implemented today, if you install bundles, I mean, the order in which we install them is typically defined by the management system. Yeah, I'll come to that later what this means. But basically an external entity starts and installs and starts the bundles. And if this management system, for some reason, installs, it can be that several bundles, say for example you have an X10 bundle, which brings its own serial port package, and you have, I don't know, some other security camera bundle, which also has a serial port package. And whichever one you install first, even if the first one has the lower version, this package is put in the framework registry as exported, and then the second one that comes along, say you install your X10 first and it has a version 0.9, and then you install your other security camera package, which comes with a serial port version number 2.x. The 2.x one gets ignored, and instead it actually imports the 0.9 from the first bundle. And this can lead to quite some confusions if the second bundle actually requires some features of the 2.x bundle or 2.x package. So that's why with the upcoming 3.0 release, this was actually addressed, and for different major numbers, they have different different versions of it installed. Because the problem is, you need, from a Java perspective, you need to agree on one particular package that everybody uses. Because if you would let different bundles use different versions of the same package, you would get very interesting class cost exceptions. Because you could have an instance of serial port, which is loaded through the one bundle, that you try to assign to, or try to compare with an instance of serial port that was instantiated from another package, and you compare two instances of serial port and you get a class cost exception because they have been loaded through different class loaders. And so it was a necessity to figure out which one to use, and unfortunately it was chosen to just use the first one that comes along. Yep.
So what kind of requirements would there be for provisioning back-end servers to provision these bundles to, say, over a wireless network to an OSGi platform someplace?
Okay. Yeah. I'll just answer this one. I think there's a little bit information in slides later, but OSGi traditionally was based on an API specification. So, I mean, there's other standards bodies, like for example DOCSIS, who do protocols, or I don't know who does WML or web. But OSGi is strictly API. So there is no management protocol that a management backend could talk to. But instead there is a management API on the framework. So what you would have to do is you have to install a management bundle that talks your specific protocol, and then this can talk the management API to the framework. So this bundle would sit as like a kind of a proxy on the gateway, which knows how to get in touch with your backend system. The problem is how it gets there initially.
Right. That's my point. I was thinking more of JSR 124, which is the provisioning spec, sort of for provisioning servers. And I know they're targeting OTA provisioning right now for mid-peak-time devices. Yeah. But I'm looking at CDC like the devices and OSGi bundles. How would they target that? And that's, I guess, my question is there a...
Yeah, I mean, for like JSR 124, I actually haven't read it in detail. I was pointed to it like a few times now. I finally have to stop and read it. But yeah, so the idea how this would work in an OSGi world is that when you initially assemble the device and you put the OSGi framework on, you just put basically on the flash of the device, you put a JSR 124 bundle that knows how to get in touch with your Java vending machine backend and talks the appropriate protocol. And then you could integrate it. The other thing that maybe I should clarify here, because a lot of people always get scared of the O in open. I mean, everybody here hopefully knows that open doesn't mean that everybody can do everything. It just means the specification is open. But I know like 2 years ago or so, I was talking to people in the cable industry about those OSGi gateways, and they were scared, like really. I mean, they were badly scared without using any bad words here, and because their fear was that, oh, we're going to deploy OSGi gateways to those houses, and then people start just downloading random applications on them, and it's like a free-for-all platform, and everybody can install whatever, and it's going to be this big chaos. But no, an OSGi platform is not really open so that everybody can install everything. It's like, it's a programming platform that's an open standard, and people can use it to build closed proprietary gateways. If you put a management bundle on it that only talks, say for example AT&T deploys this and their management bundle only talks to the AT&T backend, it's completely under their control which bundles get downloaded to this framework. And if you have another service which you would like to provide to all the AT&T customers, you have to talk to AT&T and they have to funnel it through their backend. So, okay, as I mentioned a number of times now, the framework can install, update, uninstall bundles dynamically. And I must say that dynamically is really it's the cool part about it. That's really the cool factor, to develop applications that can dynamically appear and disappear. And it's quite interesting. There's actually another framework out right now. Try to remember the name of it. It's been published by IBM. It's the they use it as a development tool framework, and I have to look up the name. I don't know anymore. Taglets. Sorry. Taglets. AGLETS. No. It's an IDE framework. They position it competing to JBuilder and all those things. Eclipse. Yes. Right. So Eclipse allows you to. I've only talked with people. I've never tried it myself, but supposedly it also allows you to extend the IDE platform with additional Java code that you write, and also modules, and it has an interface, and it's very similar to what the OSGi framework is intended to, but they only allow you to specify all those Java components at the startup time, and then they link everything together, and as it starts up, everything becomes hard linked, and the dependencies are more or less set in stone. Whereas with the OSGi framework, the cool thing would really be you can, during runtime, just deploy a new module, and then suddenly a menu pops up in one of your pull-down lists, and you have new functionality deployed. So I've heard people actually talking about using the OSGi framework as core of this development framework now, but that's just been like a few weeks ago, so I don't know if they're really going to do it, but we talked to some people at IBM and they were interested in doing this because it's more dynamic and just cooler. So, okay, again, for management, here it is. So the framework provides the mechanisms, but per se is policy free. And the management policy is provided as a bundle. As I said earlier, it's the management bundle that you deploy. And this is specific to the operator. So whoever, or integrator, whoever basically puts the firmware together that goes on this box. And the management policies can be made and selected by the operator. There is standardized OSGi management bundles from network management vendors, and well, one of them is Gatespace, and I know at least Sun and IBM have another one. And there is also a German startup called, or not startup, they've been around too long now, but it's called Process. They also have a management system. So there is at least 4 or 5 out there now. This is pretty much what it looks like. As I said earlier, OSGi specifies the API. It doesn't really specify the protocol itself. So it would look like this, that we have a management system on the back end, and we have a corresponding here corresponding bundle that talks to the management system. And then we can implement whichever private protocol, SNMP, CIM, SyncML, between those two. It's a collaborative model. It's more than an applet. It's more than just midlet or whatever let runner. I mean, there's so many different standards with Java for implementing little pieces of code. The idea here is, I mean, bundles are expected to collaborate with each other. Applets don't. I mean, an applet is just standalone entity. You start it, you run it. Those here share packages and they interact through services. And then there is a dynamic registry, as I said, that allows bundle to find and track services and to get notified. So there's all this event mechanism how to get notified for bundles either coming or going. And the framework takes care of all these dependencies. So, and that's a side note. My personal opinion is that the OSGi framework is something that Sun should have put into the Java specification in the first place, because the dynamic class loaders, they were a pretty good idea, but they stopped somewhere halfway through. So the functionality of the OSGi framework is something which really would supplement a standard VM very nicely, and I think it's a nice programming model. And I have started doing almost all my work based on OSGi frameworks. I've implemented lots of weird things on top of OSGi frameworks that have nothing to do with gateways or anything. It's just, I don't know, it's a neat programming model. How this works is, so here we have the stack again with the operating system Java and the OSGi framework drawn on top. And we can load different bundles. Each bundle can interact, as I said earlier, with the JVM, with the operating system, with the hardware, and with the framework. And when we get a second bundle, then those bundles can share packages. So each bundle can load packages from its own jar file or from shared packages. And they can also, through the framework registry, they can share services between each other. If we compare this to other OSGi compared to MIT-P or Java TV or applet browsers, then in all the other models, for example, an applet can't really access the native code and can't access the hardware. There's all the sandbox model. I mean, you can have signed applets, but I don't know who uses signed applets. I haven't seen one in a long time. So the other thing is you can't really share packages or anything in between. They even typically run on different virtual machines. And they usually don't, or there is no way for collaboration between them. They're only standalone entities. So that's all the things that we lose by not using the OSGi framework. Oh yeah, and there is no management. So the Java application manager, all it is basically just loading the bytecode, executing a virtual machine, and running the bytecode. But it's not really managing it. Then, so we've talked about bundles, so now let's see services. So a service is an object, is an instance of an object registered with the framework. It's typically registered by one bundle in order to be used by another bundle or multiple bundles. And in the following, it's drawn as a triangle. The semantics is that it's defined by a Java interface, so that's how you define the service. And you obviously implement it as a Java class. And yeah, the interface definition of a service is typically shared as packages between the bundles, just as an implementation note.